So, what do I have in store for you today? Okay, today we go into the Modeling with CNOSSOS-EU Part 2. In the previous webinar, I explained about the CNOSSOS method and the source models and the XML file format. And now we'll go into some more detailed settings on how to create a model, how to create receivers at facades, the calculation setting, how to tile a model, and how to get your EU population exposure. And then at the end of the session, I will open up for questions and answers. Okay. The previous webinars are all available at the SoftNoise website. And so we started in January this year. SoftNoise is now selling one-year rental licenses directly. So that's why we have made the first webinar on the Predictor introduction and the new portfolio. Then there's a webinar on noise prediction and mapping, where I present the methods available worldwide, the theory behind the methods, and the process behind a noise mapping project. The third webinar was on GIS and CAD data import, and the fourth webinar was modeling with CNOSSOS Part 1. And like I said, I explained a little bit about the CNOSSOS method and specifically the road and rail source models, because every member state in Europe has to create its own XML file with the parameters on how to calculate the sound power level of the roads and the rails in the specific country. So you can watch them all on our website, softnoise.com webinars. The latest information on CNOSSOS-EU that I have is that it is expected in May this month that a revision of the CNOSSOS method will be sent to the noise expert group for review. I have not seen a mail yet, but I'm really looking forward to receiving it. And these modifications in CNOSSOS will be based on the REVM report from August 2019. As you know, there were several issues in the CNOSSOS method and they need to be solved. So the intention, as I understand, is to have this updated CNOSSOS method accepted by Brussels before the end of this year. And also, if you look at the quality assurance, the latest version is still a draft from October 2019. And it's unclear if this quality assurance standard will be updated or need to be updated based on an updated CNOSSOS method. Because in the current quality assurance, this draft from October, there are already specific issues solved that are in the new revision. Anyway, I'll come back on that on other webinars. So we go into the first part of the CNOSSOS method, how to create receivers at the facades. And the CNOSSOS method defines two cases, case 1 and case 2. This is case 1, where facades are split up in regular intervals. And you have to realize that only for buildings with single dwellings, the most exposed facade noise level is directly used for the statistics. That means that you need to have a function per building. So you need to know which buildings are considered to be single dwellings and which buildings are considered to be multi-dwellings. And for a single dwelling building, you have to assign all people to the most exposed facade. And for multi-dwelling buildings, you have to use the ratio of the facade length divided by the total length. So there's a difference between single dwelling and multi-dwelling, and that's already interesting to realize. This is a copy of the text of CNOSSOS-EU, and the red text is the changes, the suggested changes by REVM in their report to the EU. So this might already be the updated CNOSSOS method, what I talked about. So this is case 1. Case 2, That's where the facades are split up at the set distance from the start of the polygon. So there's there's the same length of facade between all receivers. And there's a case 2A and 2B because facades are considered separately or split up every 5 meters from the start position. So even within case 2, there are already 2 cases. So that's why also, as you can see later in this demonstration in Predictor, you can choose between case 1, case 2A, and case 2B. Okay, this graph gives an overview of the project flow for a EU noise mapping project. And I will demonstrate part of this project flow. First, you have to import your data of the buildings, the ground regions, the height lines, and they of course come from a GIS system, and mainly they will be in shape format. You import them in the main model in your Predictor project. Then in the main model, you will create receivers and facades, and you will tile the model. Some cases it's not needed tiling. I will come back on that later, but in some cases it is needed. And I will also explain you why and when tiling is needed. So when you tile, you've got several tiled models, all within the same Predictor project. You can then calculate the tiled models in a batch way. So you can do a batch calculation. And after the calculation is finished, you can do a batch export of results of all the tiled models. And the result is that you have one file with all the calculated results. So those are your noise levels. But then you need the population data. And that's done by using address points. So you also have to create or import address points in your main model. And then you can export and create an EU population file. These are the 2 main files that you need in order to calculate and determine the noise exposure. And if you have these 2 files, you can calculate the noise exposure, for instance, in Excel or in a GIS system, but you can also do it in Excel. Okay, so that's the overview I want to show you today. So now I will start a demonstration and I will show you how to import buildings, roads, and a diff area, because you also have to know the boundaries of the agglomeration where you have to do your noise mapping. Step 2 is to select all the buildings within that agglomeration with a residential function, because there will be many buildings for commercial function or non-residential residential functions. The next step is to create receivers at the facades. The next step is to set the calculating settings. And then most likely you will have to tile your main model. These are the steps I'm going to show you now. This is a Predictor project, and this is the project structure. I'm not going to explain that. I've done that in other webinars. I'm going to create a new model, and we're going to call this RNM demo. I'm going to select the calculation method Lima CNOSSOS. Say OK. So now the new model is added to the project structure. So I'm going to open this newly created model. This is of course where you start. You have nothing. Next, I'm going to import. Let me just. Yeah, that's OK. I'm going to import the buildings. So I'm going to select the building shapefile. And I'm going to select the building item to create your buildings. And I've explained the importing of shapefiles or GIS files and CAD files in a separate webinar, as I told you at the start of this webinar. So you can always look in more detail how to import CAD or GIS data. So these are my buildings. Note that I've also put a thematic presentation option, because all buildings have a parameter, a property called function. That's designated use. And I've now selected all buildings with a function that includes dwelling. And that means that all my dwellings are now colored in a greenish color. So if I zoom in, you see that these are now all dwellings, because this is a multi-dwelling, and there are also single dwellings. Maybe this is a single dwelling. Yeah, this is a single dwelling. So that data comes from a GIS system, but all the sheds in the garden are of course not considered to be dwellings. Okay, next I'm going to import the road structure. So these are my roads. And then of course I have to create roads out of this shapefile. Okay, so now I've imported my buildings and my roads. I'm also going to import a diff area, and that's in fact the agglomeration boundary. And I'm doing that at the diff area. Diff items are items that are not important for the calculation, but are very useful to do all kind of other things, selections, etc. So this is my main model. Next, I'm going to create receivers around the facades. But of course, I only want to create receivers around facades for buildings that have a residential function. So what I'm going to do is I'm going to hide everything. Then I'm going to switch on my buildings only with the residential function. So I'm going to deselect the other type of buildings. Also going to show my diff area. So what I see now is my agglomeration boundary as an example, and all the buildings with a residential function. Next, I'm going to select my agglomeration boundary, right mouse click, select with polygon, and I'm going to select all the buildings inside, the items inside. And because I only are showing buildings with the function, with the residential function, I'm going to select all the buildings inside the agglomeration with the residential function. And now I can create receivers around facades. So now I'm going to go to the edit, batch create items, and now I can create receivers at facades. Like I said, here you can select between the CNOSSOS case 1, case 2a, and case 2b. So just select case 1, click on create. Going to switch up. So here you see the receivers being created, almost 100,000 receivers. And the changes are saved. Okay, so now I can switch on my receivers. And my receivers are shown in a blue color with a dot. So if I zoom in, and I'm also going to select the other buildings again. So what you see is that for the sheds, there are no receivers created around the buildings. And here are all the buildings, all the receivers around the buildings, all the blue dots. I can also show my receiver as a nice microphone symbol. Then you might recognize it because the microphone symbol is the default symbol for receivers. But for such a big model, of course, a dot is much more efficient. So that's how I want to change it to a dot. Okay, so what I've done so far is imported the buildings, the roads. I'm going to show the roads. My roads, here are my roads. And I've created receivers around all buildings within the agglomeration that have the function dwelling or residential use. Okay, so now I'm going to show you how to tile such a model. but before you tile the model, you have to set the calculation settings correct. So I go to Calculations, Settings, and in this case, I only want to have total results. It's not necessary to have group or source results, total results. And this is an important setting, the fetching radius. In this case, I'm just going to use a fetching radius of 2,500 meters. I will come back on that later, but that is of course the area of interest around a calculation point. And when you have a big model, it makes no sense to calculate the contribution for a road 10 or 20 kilometers away on a certain calculation point. You do not increase your accuracy and you only increase your calculation time. So this is an important one, fetching radius. There are also some other important settings like the reflex and the situm. The reflex here, the 0.5, that's important because all receivers within 0.5 from a facade do not get the facade reflection. And that's of course exactly what we want because I've created my receivers around facades on 10 centimeters distance. So this parameter should be bigger than 10 centimeters. In the help, all these settings are explained. Okay, tiling. Tiling is done with tile model. Once you execute the tiling process, it will create an area, an additional area in your project. It will create a version, and in this version folder, all the tiled models will be stored. Let's suppose that, and of course, your tile size and your buffer size are important. I will come back on that later. Important to remember now is that the buffer size, in many cases, is the same as the fetching radius. Okay, I have to adjust my tile positioning on the calculation points. Then I click on Execute, and now all the tiles are created. And in this case, there will be 4 tiles created. This is the first tile. You see the Save Changes. So there's of course a lot of work for the computer. A lot of clipping is done, taking out items that are not needed for that specific tile. I will explain that later, but I just want to finish my demonstration here. The third tile, and then the fourth tile is created. Okay, so after the tiling is finished, what you see is there's one new area. There within this area a new version, and in this version you see all the specific tiles. Let's now switch off a microphone. Somebody has Shibon. Okay, yeah, okay. Okay, so these are the tiles created, and I will open these tiles, and also a tile map is created, but let me first open the 4 tiles. First tile, second tile, third tile, fourth tile. These are of course bigger models, so it will take a couple of seconds per tile opening. Okay, now I can do window tile vertical. And here you see all your tiles. It's tile 3, tile 4, tile 2, tile 1. I can close the demo. And then tile vertically again. So if you do a Control A and then do a home. Okay, so this is tile 1. What you see is that all the receivers are clipped, and there's a buffer zone of 2,500 meters around to include all the objects. In this tile, tile 4, you see that the receivers are clipped in this part of your agglomeration. And then, of course, you don't need all the objects that is further away than 2,500 meters than this receiver. So here you see the objects below, and here you don't. So this is all the tiles. You can also put as a background model the tile map. So these are the 4 tiles created. This is tile 1, tile 2, tile 3, tile 4. So that's how the tiling is done. And then, of course, you need to start your calculation. You can either do a local calculation, or in the new version that is coming, 2021, you can also do a cloud calculation. And I will come on back on that later. What I've shown you is step 1. I've imported the buildings, I've imported the roads, and I've imported the diff area, the agglomeration boundary. Step 2, I've selected all the buildings within the diff area, this agglomeration, with a residential function. And I made use of the display options in the sidebar. I made a thematic presentation, and that made it very easy to select and deselect specific buildings. Step 3, I created the receivers, and with this option, create receivers at facade, and I've selected case 1, and the distance to the facade was 0.1 meter, 10 centimeters. And that's important because the calculation setting said all receivers closer than half a meter to the facades do not get a facade reflection. And that's exactly what we want, because we want an incident noise level. Step 4, I created the tile models. I used a similar buffer size, similar to the fetching radius. And after the tiling is done, there were 4 tiles, and a new version was created, a new area, a new version within the area, and within this version, all the tiled models and the tile map was created. And then, of course, you need to calculate the 4 models. Yeah. But that's no work for you. That's some number crunching by computers. Okay, coming back on the calculation setting, as I explained, the fetching radius is an important one. In the previous webinar, I explained about the meteorological correction, about average temperature, etc. But for the calculation, also, of course, this fetching radius is important. It's a distance in meters around a calculation point, and only those sources and objects that are fully or partly within this fetching radius are taken into account. Other items will therefore have no influence on the calculation. Then I've shown you how tiling works. Tiling is an option in the G, the A, and the B configuration, and the 2 smaller configurations, the I and the C, do not support tiling. So when do you need tiling? Well, you need tiling when the terrain model has more than 1 million terrain edges, because one predictor model can only have 1 million terrain edges. Well, the model itself, you can have more terrain edges. However, for the calculation, the model during calculation can only contain 1 million terrain edges. So you can create a main model with millions of terrain edges, then do a tiling, and then every tile needs to have less than 1 million terrain edges. Another reason for tiling is when the number of obstacle edges or the number of emitters is too large for your license. Because a 7810G license, that's a standard model size, can contain 4,000 emitters and 20,000 obstacle edges for the calculation. Again, you can create any size of model you want, but when you press calculation, there's a check on the model size. So 7810G, 4,000 emitters. An emitter can be seen as either a point source or a segment, a line segment of a road or a railway. That's one emitter. So before your calculation is started, your line sources are segmented, and then every segment is considered to be an emitter. For the plus size model, you can go up to 12,000 emitters and 60,000 obstacle edges. And an obstacle edge, that's a node for a building, for instance. If a building has 4 corners, then this building also has 4 obstacle edges. And then the advanced model size, you can create for the calculation 200,000 emitters and 1 million obstacle edges. So in fact, Arnhem, for Arnhem you do not need to tile because Arnhem fits in one advanced model size. However, Paris or London do not fit in one advanced model size. So there you really have to tile. Coming back on the tiling, I explained it already a little bit. You've got a tile and a buffer zone around the tile. And receivers are clipped outside the tile zone, and outside the buffer zone, everything else is clipped. So that's how the clipping works. And all tiled models have the same calculation settings. So you tile the main model, and then all the tile models have the same calculation settings. That's why you first need to define your calculation settings before you activate the tiling option. Okay, the last point of my presentation is about address points, and I will not go into that in much detail. I only tell you that an address point, that's a location, and it should be located inside a building because it says something about the building. It says how many people live in this building and how many dwellings does this building contain. So this is important information for the EU population data. So this is in fact your population data that you need. You need to import this data. And let me open the main model again. This one. Now switch on the address points. And this is all done on my simple laptop. So this is not a heavy duty computer I'm using. I'm simply using a normal laptop. Okay, let me go import shapefile. I'm going to import the address points. I'm going to create address points out of this shapefile. And the address points I've given a slightly brown color. Okay, 70,000 address points. So if you zoom in to the model, you see here that this is an address point. Double click on the address point and oops, location info. That's one resident, one dwelling, and one person living there. And then you see the receiver points around the facades. So every address point needs to be located inside the building. Presentation again. So that's an address point. And you need, oops, sorry about that. You need to have these address points in order to be able to use a new EU population expert option we're building now. And the next version hopefully will be released in somewhere in June or July. So quite soon. And this new EU population expert will create a file that will have these attributes. This file will have the receiver ID, that's unique within the Predictor project, the building ID, the number of dwellings represented by this receiver, the number of people presented by this receiver, the designated use of the linked building, and then some informational data like the total facade length of the receiver, the total numbers of the dwelling of the building, the total number of people of the building, and the facade length of the specific receiver. But that's only informational. This is the important data. And and once you have that data, so this EU population data, you can link the two based on the receiver ID. And then you can count the number of dwellings per 5 dB noise classes. So coming back on the project flow, what I've done is I've imported the objects. I imported the agglomeration area. I selected the buildings within this agglomeration area with the residential designated use to differentiate, for instance, between single dwellings and multi-dwellings. I created the receivers around the buildings. And note, in the next version, the facade length will also be added during this creation because we need that facade length per receiver. Then I've set the calculation settings. Fetching radius is important. Then I tiled the models, and note that the buffer and the fetching radius will be the same. Then, of course, you need to calculate the tiled models, either with a local batch calculation or a cloud calculation. And after your calculation is finished, you can create one result file with the menu option File, Export, Batch Export Point Results. So that's all for your calculation. Then for the EU population data, you have to import address points in your main model, and then you can export your population data. And then the last step, of course, is to determine the number of exposed people and dwellings, but that can be done with a simple table join, for instance, in Excel, because the two files have unique receiver ID and unique building IDs. So hopefully you're still awake. This I've shown you, the project flow. Then something about the cloud calculation in my next webinar, Tuesday the 9th of June. You can already register for this webinar. I will go into the new version, Predictor 2021, and cloud calculations. I will give you a sneak preview. And the benefits of the cloud calculations is that you do not need a hasp key. You can use it from any location, also from your home. It will give you a faster calculation, just as easy as local calculations. And during the cloud calculation, you can use Predictor for modeling and local calculations. You've got no performance loss on your local PC, of course. You can even switch it off, and you are notified by email when the calculation is finished. Of course, one of the major benefits is that you do not have to invest in additional hardware, and it's safe and secure. We use an ISO 20001 certified data center in the Netherlands, and we've got a certificate secured HTTPS connection. So that's exciting new news, but I will come back on that in the coming weeks.